Hey. Okay, hello everybody, my name is Olaf. I'm a technology advisor at CircleCi. Who's familiar with CircleCi? Few hands. A little bit about CircleCi. So Jenkins was founded in February 2011. Our first release was November 2011. So we lost. But we're still here. Not open source, we're a commercial company, founders from Ireland, but then they moved to San Francisco, as anybody does. And we're still alive and kicking, maybe not so well known in Europe, but I'm from Amsterdam, Netherlands, so I try to talk the story for Europe. Lots of clients ranging from Meta, Hugging Face, Palantir, to small ones, startups, scale-ups, anything in between. We have free plans, we have commercial plans, and about 500 people worldwide. Latest office, Mexico City, which is nice, so I can travel to Mexico, have a good excuse. And this talk is going to be about the changes that we see in CI/CD. Obviously, AI, right? So how did we do things in the past? In the past, things were simple, right? Code, build, test, deploy, monitor, and you circle around. Everything was simple, very deterministic. What can go wrong? But now, all of a sudden, we have intelligence. Something, AI, agents, MCP servers are in the loop, and they are learning and changing things, and all of a sudden, our code is changing, and new tests are happening, and it's like a black box, and why is this thing not working anymore, and who created this MCP tool, and things are really getting like tricky. And what we are noticing, and I'm not sure if this is familiar with you guys, the SDLC, the software development lifecycle. First, it was kind of like, you know, the 8 pattern. So we would build things, and then at some point would be productionized. But what we're now seeing is that these two worlds are kind of getting separated. So we see the inner loop, the development loop, is speeding up. All of a sudden, you have people with MacBooks, M1s, M2s, M3s, M4s, which are faster and more powerful than your typical VM that you can hire from Amazon or Microsoft. So the developers are like, why can't I do this stuff on my machine? Actually, we see customers moving the build agents to the developers' machines again, because that's cheaper. The machines are there, they can do it. So we see this inner loop, the development loop, speed up. It becomes really fast. On the other hand, the outer loop, the integration test, the end-to-end test, testing third parties, external APIs, becomes much harder because the complexity increases. So we see, like, how can we kind of get these two frequencies, how can we make them work together? And the last thing, the non-deterministic thing, that's actually an interesting one, because I've seen cases where an agent or a co-pilot or whatever is just for fun changing regular expressions in code. Nobody knows why, because it looks better, and all of a sudden your code doesn't work anymore. And then the next day it works again, nobody knows why. So how to test for this behavior, right? And another challenge that we see is, I'm not sure if you recognize this, writing code is not a problem. Anybody can write code. Writing good code, that's a challenge, right? But everybody as an engineer says, like, my code is the best, my colleagues are, I don't know. And now all of a sudden you get this virtual colleague and it starts to spit out tons of lines of code. But that's not the problem. But the problem is that this code and all the related tests that are generated are flowing through your pipelines. They need to run every time. And that's the real challenge, because your code can increase 10 times, but your budget probably doesn't. So all of a sudden you're like, what's happening? More tests, but my budget, how can I solve this problem? So AI is not a fix, it's a multiplier. So what do I mean with the multiplier? Is anybody familiar with the O-ring theory? It's an economic theory, but it's based on the O-ring, the little ring in a space shuttle. And it was the cause of I'm not sure what the name was, the disaster, the explosion of the space shuttle. It was like one little rubber ring that didn't fit well, basically caused the entire explosion. The O-ring theory basically tells you that if you increase one little thing or improve one little thing and keep the rest at the same level, effectively in the end, you lose. You don't get any value. Raising one thing a lot and keeping the rest the same doesn't help either. In the end, the value of the output is kind of increasing a little bit. But if you lift the entire chain a little bit up, that's better. But the thing with AI is if there's a problem in your development chain somewhere, it will start to increase and it will become a problem. Because the moment the volume through the pipelines increases, these little issues become big issues and they start escalating. And that's a real problem. So basically what I'm trying to communicate here is AI can be brilliant or it can be wild. And I was at a keynote talk in Copenhagen, I think a few weeks ago, and somebody made a very nice claim. Said like, yeah, AI can be brilliant or AI can be wild, just like humans. What's the difference? Because humans are also brilliant typically, if you're lucky, but they also can make mistakes. Why do we expect a system like an AI to always be 100% correct? Maybe we need to focus on this thing a little bit different. And I've got a video in here, and I'm hoping it works, because typically... Anybody saw this video? This is a robot hanging there. Talking about a little bit wild, but the thing goes really off the rails. And now I'm looking at it and I'm thinking, this is a nice example of the black box that we're kind of like challenging with. Because people have a discussion, why is this robot acting this way? Is it trying to attack the people that made it? Or what's happening? And somebody said, like, it's simple. The thing is trying to correct itself. It's hanging on strings. So it's trying to, like, not fall over and starts to get really crazy. So we don't know yet, I think. We're still learning how AI needs to be approached. And, of course, as any engineer, you want to dog food or drink your own champagne. So I try to do, I think, like, okay, I can do this myself. So I had this challenge. Somebody asked me, like, yeah, we have like 170 old GitHub repos. Can you archive these to another organization? It's like, okay, let's give it a go. Ask ChatGPT what will happen. Can you help me, ChatGPT? Yeah. The best option, use the CLI, GH with a script. Bash script, sounds good. I'm an old schooler, bash script for the win. A few moments later, this needs to be in there, always, SpongeBob. Yeah, all kinds of questions, and sounds really nice. Do you want a dry run flag? Yeah, sounds good. Logging, sounds good. So perfect, here's your script. Webhook deletion, don't know what it is, but sounds good, right? Just add it in there. Repository transfer, that's what I want. Good, logging, love it. Dry run, love it. This is the beginning. Looks solid, right? I mean, it's a bash script. What can go wrong? This is the first part, dry run, looping. It's not too hard. Then the last part. Anybody can see what will happen? No, dry running went. This all kind of logic worked. And I mean, you see the commands. It looks like somebody that knows how to create a bash script, right? It's thought, this doesn't work for whatever reason. I said, GHCLI does not seem to have a repo transfer option. You're absolutely right. It doesn't have that feature. Why are you suggesting this to me? Really, I was looking at it. Why? And the strange thing is, it knew. It just created a script with a function transfer. Yeah, it's not real. Apologies for the confusion. Okay, thank you very much. In the end, I managed to use the API. But this is to say, it's making things up. I don't know why. It feels that it's not okay to say, I don't know, or... And I looked it up, but it turned out that there was this comment somewhere from 10 years ago where somebody said, transfer would be nice. Yeah, closed thread, gone. Basically, this thread of, I don't know, 5 posts was used in the training data, obviously, and now it starts suggesting these things. Anyway, treat AI like any human team member. I guess that's the moral of this story. So put guardrails in place, define clear roles, and make the human accountable. Like, why are you suggesting this? Can you maybe do it better next time? I think this is very important. You cannot hide behind a system. The human is still accountable. I think in other talks also, yeah, we drive the system. It's a tool. We use the tool, but we're in the end responsible. We drive it. So what kind of challenges as CircleCi with all our customers worldwide do we see? Cost is one. So increase of tests, increase of code, increase of services that are generated, increase of bash scripts that don't work, increase of flaky tests that you need to rerun. So that means cost will explode. I heard a guy from Google talk that they are expecting a 10 times increase on their internal pipelines. So they're scaling up for 10 times. Google has a money printing machine, so they don't have issues there, I think. Security is an issue, obviously. You don't know what secrets are kind of like flowing through your prompts. Scale is an issue here. Non-deterministic, I spoke about it. And this thing, if you only have hammer. I'm from the Netherlands. My wife was like, what does that mean if you only have hammer? Everything becomes a nail, right? You have AI, you try to apply AI with everything, don't do it. So where does AI excel? I think 3 main areas. Repetitive work automation, undifferentiating heavy lifting. Maybe not use the AI to do things that you don't know, right? Because how can you control or observe? How can you be responsible? Ask the AI to do something that you don't know if it's good or bad, and then say, oh, well, what's the AI? I don't know. The AI is basically mapping words together, right? So you need to be responsible there. But you can make it do things that are boring for you, or need to do, yes, automation, right? It's like the money printing, the press machine, or like steam machines. It helps you to do things easier and faster. Analyzing large data sets. We're not good in finding things in big data sets, but a machine learning engine can find anomalies and outliers faster than we can. And the natural language interface. I think it's super powerful. Instead of writing a SQL query, you can just talk to the system, ask it like, what's the slowest pipeline? Why? Can you give me suggestions how to improve it? That's much better than querying the thing and trying to understand the data structure. Cost management, challenge. But how do you manage cost? I've got 2 kids. How do I manage the cost of their phone bill? Capping, just limiting, alerting. And you need to do it, because if your agent starts doing MCP things with other virtual machines or AWS MCP service, before you know it. I heard a guy from Liberty talk about a team spending £20,000 in 2 hours because their agents went berserk. Luckily, they had capping, so at some point, the thing stopped. Caps and guardrails, best practices. Make sure you fence these things off. That's important. Security. Sandboxes, sandboxes, sandboxes. Fence it off, make sure that these things don't go out, don't go into IP ranges that they're not allowed to do. Bring your own model, that's also interesting. Bring your own keys, keep control of the things that are important to you. Sanitize things, scrub it, clean it. You don't want secret passwords being shared in prompts. And maybe templates, just templates with placeholders. Give the templates to your team, say this is the prompt template that we allow. Rest, we ignore. Just training wheels, right? Just start learning and go slowly. Scaling complexity is a big problem. You don't want to blow up your pipelines, you want to optimize your pipelines. So I had lots of chats these days about, we have tons of data. How tests are running, what parts of the code have been changed, did we do a rollback, how much comments in the PRs are about this code change. We don't use that data, typically. We don't correlate it. So if we can be smarter about the data, we can work much more efficient. If only the front end is changed, only run these tests. If only this back end has changed, only run these tests. Maybe if this test is flaky, don't run it, fix it first, skip it. So these things are all important to be more efficient with the data that you have instead of doing everything or nothing, because that's typically the case 8 out of 10 times. We run all the tests because we want to be sure. Yeah, if you do that all the time and then your pipelines go 10 times, it's becoming really expensive. So, like I said, stay in control while you accelerate, because you will accelerate. Things will move because people are using Copilot, Claude. These things, Pandora's box, they will not go away. They are there, they will be used, so you better put controls in place. And that means that you need to put AI layers for learning in the loop. That's important, and the accountability again. In the end, a human needs to be accountable. That's really, I think, the gist of this talk. Now a little bit how this kind of theoretical but very applicable, I think. So in our platform, how do we apply these learnings? We have 3 main pillars. We have intelligent summaries, which is the natural language, talk to the system, let the system talk to you. The MCP server, obviously, and chunk, trademark. It's legal. Needs to be trademarked, I don't know why, but it's the name of our AI agent framework. So this is the first, like a screenshot. You see the thing there on the right, it's a little bit blurry. Explain this error, it says. So you can click on explain this error, and then it starts telling you in natural language why this is an error and how you can fix it. So that's nice, because you don't need to understand the APIs or the interface. You can just talk to the system. Of course, we have MCP tools these days, and they are growing. So you see, you can do things like get build failure logs, find flaky tests, help me with my configuration, why is it failing, run this pipeline, rerun this pipeline, recommend optimizations, etc. And this is our VS Code integration. So it says, fix the issue from CI. Sounds very fake, but it's a test, I guess. So you can talk to the system, and then the MCP tools will be used by an agent to help you to fix things or optimize. And then basically you can do all these things that will happen in your VS Code, so you don't need to context switch. And chunk, like I said, is the 3rd pillar. It's kind of like where all this stuff comes together. It's kind of like a framework or a plugin framework for agents and integrations into CI/CD automation platform. So it can do autonomous fixes, like fix flaky tests automatically for me, or maybe do a PR and then let me sign off as a human. Adaptive intelligence means it can learn from the data. Like I said, we have a lot of data. If we parse this data, analyze it, we can become smarter. The orchestration thing, you can automate more. And this last thing, bring your own key. I think we're in Europe. We all know the things about DORA, the Resiliency Act. We all understand the things that when a US company has US employees, they can access our data even though they're in the data center in Europe. So if you have your own private keys under your own control, doesn't really matter where the data lives, because the encryption is in your control. That's an interesting one. So this is a view of chunk. It basically, you define the number of tasks that it can run. Like I said, these are guardrails. How many times a day? What tasks does it need to do? Maximum tests per run. You can kind of cap it or limit it. And then you see all the tasks that it basically is working on. It detects the flaky test. It can suggest fixes for it. And flaky test is the thing that we focus on a lot, because that's where we see a lot of time and money being spent, because they're not consistent. And people basically rerun the pipelines until the test goes green, and then they're happy. And then you still have dodgy code probably in production. So this is like the configuration that you can do. You see the tasks here that it created for itself. You see a PR opened by this chunk agent. It says, okay, I've got a random test and I've determined how to fix it. You can open it in your Git or whatever you use. You can see what it's kind of describing to you. And then you can merge it or not, depending on you. So again, like I said, human in the loop, human is responsible. You cannot like hide yourself behind these things. And this is interesting. This is kind of like the guardrails, best practices. So you can give it instructions, what it can do, what it cannot do, how it should behave. And of course, this can grow. These are basically best practices within your organization. I like the last one. Complex algorithms must include explanatory commands. So no verbose magic. It needs to be explained so people can understand what's happening. What's next? Because I'm minus 20 seconds and we have lunch coming up, so I understand we are hungry. Natural language interface, more talking to the system. Adaptive testing, based on historical data, we can basically predict that you need to run this test in this order, fail fast. If this fails, ignore the rest. Because we knew from the last 1,000 times that the rest was basically irrelevant. Test management and build optimization is right sizing. Basically, what kind of scale of build agents do you need based on your code and what is changing. Yeah, it's not about moving faster, it's moving more efficiently. That's the challenge. And again, like I said, fundamentals don't change. Adding AI basically brings out the good or the bad things in your pipelines. Oversight, keep control as a human, you're responsible. And use AI responsible. And this is the takeaway quote. AI won't replace DevOps. But teams that don't use AI will probably be replaced by teams that do. Think about it. Thank you very much. My name is Olaf, CircleCi. Thank you for your attention.